Write the value of limit extends to c f of x minus f of c upon x minus c. We know that if f is differentiable, if f of x is differentiable, at a point where x is equal to c is given by f dash of c is equal to limit extends to c f of x minus f of c upon x minus c. So we can say that the value of limit extends to c f of x minus f of c is nothing but f dash of c. Okay. Write the value of limit extends to a x into f of a minus a into f of x upon x minus a. So let us simplify this. Limit extends to a x into f of a. Let us add and subtract with a times of f of a, and then minus a times of f of x divided with x minus a. So which can also be written limit extends to a. So we can take f of a common and we can write x minus a, and here we can take minus a common and we can write f of x minus f of a upon x minus a. So which can be written as limit extends to a f of a into x minus a upon x minus a minus a times of f of x minus f of a upon x minus a. By algebra of limits, we can take separately limits for, and here we can cancel this x minus a in the numerator and denominator, and we can write limit extends to a f of a minus limit extends to a into f of x minus f of a divided by x minus a. So here f of a is an independent of x, so it is a constant, so we can write f of a minus, and here we can write by using algebra of limits, we can take a separately outside, a into limit extends to a f of x minus f of c upon x minus a. So which implies that, which is equal to f of a minus a into, since we know that f is differentiable at a point x is equal to a, if limit extends to, or at a point x is equal to c, limit extends to c, here x is a, sorry, f of x minus f of c upon x minus c is given by f dash of c. So we can write a into, here extends to a, f of x minus f of a divided by x minus a. From the definition of differentiability, we can write f dash of a, so that we can give the answer as f of a minus a into f dash of a. If x less than 2, then write the value of d by dx of root over x square minus 4x plus 4. And we know that x square minus 4x plus 4 is equal to x minus 2 whole square, and hence root over x square minus 4x plus 4 is equal to square root of x minus 2 whole square, which is equal to mod of x minus 2, since we know that root of x square is mod x. And here mod of x minus 2, which is equal to plus of x minus 2 when x is greater than or equals to 2 and negative of x minus 2 when x is less than 2. So we can consider the square root of x square minus 4x plus 4 is nothing but mod of x minus 2. For x is less than 2 we can write negative of x minus 2. That is d by dx of negative x plus 2. That is d by dx of minus x plus d by dx of constant 2. So differentiation of negative x is minus 1 and differentiation of constant is 0. So the answer is minus 1. If pi by 2 less than x less than pi, that is x belongs to the second quadrant, then find d by dx of root over 1 plus cos 2x upon 2. So differentiation with respect to x, root over 1 plus cos 2x upon 2. Let us simplify this. Root over 1 plus cos 2x upon 2, which is equal to, by using the formula cos 2x, we can write 2 cos square x minus 1 upon 2. So we can cancel 1 and 1, which is equal to root over 2 cos square x upon 2. So we can write root over cos square x, which is mod of cos x. And since x belongs to pi by 2 comma pi, that is in second quadrant, cos is negative. Cos x is negative in second quadrant. So we can say mod of cos x is equal to minus cos x. Therefore, root over 1 plus cos 2x upon 2 is equal to negative of cos x. So the differentiation d by dx of root over 1 plus cos 2x upon 2 is nothing but minus cos x, which is minus d by dx of cos x. So differentiation of cos x is negative sin x. So we can write minus of minus sin x, which is negative of negative is positive. So sin x is the answer. Write the value of d by dx of x mod x. Let us simplify x mod x. So we can write x mod x is equal to x into x, that is x square, when x is greater than or equals to 0, and we can write x into minus x, that is negative x square, when x is less than 0. So let us consider the two cases. For x is greater than or equals to 0, and since we know that mod x is not differentiable at x is equal to 0. So let us consider only x is greater than 0. For x is greater than 0, so we have d by dx of x mod x is equal to d by dx of x square, which is equal to 2x, since differentiation of x power n is n into x to the power of n minus 1. So differentiation of x square will be 2 into x power 1. And then for x is less than 0, we have d by dx of x mod x, which is equal to d by dx of negative x square. So we can write here minus d by dx of x square, which is equal to negative 2x. So we can just conclude that d by dx of x mod x is equal to, therefore d by dx of x mod x is equal to, we will get two answers based on when x is positive it is 2x and negative 2x when x is less than 0. Write the value of d by dx of x plus mod x into mod x. Let us simplify. First, x plus mod x into mod x, which is equal to x into mod x plus mod x into mod x, that is mod x square. For any real number, x belongs to R, so mod x whole square is same as x square. So we can write this as x into mod x plus x square, and also from the definition of modulus function, mod x is equal to x when x is greater than or equals to 0, and it's a negative x when x is less than 0. So we can write here two cases, which is equal to x into x plus x square, that is x square plus x square, which is equal to 2x square when x is greater than or equals to 0, and the same thing we can write x into negative x plus x square, which is equal to minus x square plus x square, which is equal to 0 for x is less than 0. So two cases we got it. For x is greater than or equals to 0, 2x square, and for x is less than 0, 0. So let us differentiate now. D by dx of x plus mod x into mod x, which is equal to differentiation of 2x square when x is greater than 0. We will not consider is equal to 0 because mod x is not differentiable at x is equal to 0. So we will consider only x positive. So differentiation of 2x square is 2 into 2, 4x, since we know that differentiation of x power n is equal to n into x to the power of n minus n into x to the power of n minus 1, and differentiation of the next one is 0, so we will be getting 0 for x is less than 0. So we can give the answer 4x when x is positive and 0 when x is less than 0. If f of x is equal to mod x plus mod of x minus 1, then write the value of d by dx of the function f of x. It's very clearly, we know that f of x is equal to mod of x minus a is not differentiable at x is equal to a point. So where you are getting mod is 0. So clearly we can say that this function f of x is not differentiable. It's not differentiable at 2 points, at x is equal to 0 in the first case, mod x, and x is equal to 1 in the later case, that is x minus 1. So let us divide into 3 intervals. So whereby the critical points is 0 and 1 is dividing entire real numbers into 3 parts, where x is less than 0, for x less than 0, and for x lies between 0 and 1, and for x is greater than 1. So when x is less than 0, so we can say mod of x is equal to negative x, and mod of x minus 1 will be taken as minus of x minus 1. And in the case of 0 to 1, mod x is equal to plus x because it is above 0, and mod of x minus 1 will be considered negative of x minus 1. And in the case of x is greater than 1, mod x will be considered plus x, and mod of x minus 1 also considered to be positive. So we can consider plus of x minus 1. So let us substitute here. So our function f of x, we can write it as f of x is equal to mod x plus mod of x minus 1, which is equal to, in the 3 intervals, in the first interval for x less than 0, mod x is negative x and mod of x minus 1 is negative of x minus 1, So which is equal to, on simplifying, minus 2x plus 1 for x is less than 0, and the next one for x lies between 0 and 1, mod x is x minus of x minus 1, so which is equal to plus 1 when x lies between 0 and 1, and the third case when x is greater than 1, so we can say here x plus of x minus 1, which is equal to 2x minus 1 when x is greater than 1, three cases. Then the differentiation of f of x in the three cases is equal to differentiation of d by dx of minus 2x plus 1, which is negative 2 for x is less than 0, and differentiation of the second part, differentiation d by dx of constant is 0 for x lies between 0 and 1, and third part d by dx of 2x minus 1, which is equal to 2 for x is greater than 1. So you're getting the three parts. When x is less than 0, differentiation is negative 2, and for x is lying between 0 and 1, it is 0. For x is greater than 1, it is 2. So these are the three values. Okay. Write the value of the derivative of f of x is equal to mod of x minus 1 plus mod of x minus 3 at x is equal to 2. And we know that a function f of x is equal to mod of x minus a is not differentiable at x is equal to a. So this function is not differentiable at x is equal to 1 in the first case and x is equal to 3 in the second case. And for x is equal to 2, which is lying between 1 and 3, since 2 lies between 1 and 3, so let us consider the interval. For x lies between 1 and 3, mod of x minus 1 is equal to, because x is greater than 1, so it will be x minus 1, and mod of x minus 3, it is below 3, so we can consider negative of x minus 3. So let us substitute here f of x, since we required for x is equal to 2, that is for x lies between 1 and 3, for x lies between 1 and 3, f of x is equal to mod of x minus 1, we can consider x minus 1, and mod of x minus 3 we can consider negative of x minus 3. So which is equal to, on simplifying, x minus 1, negative x and plus 3, so x and x get cancelled, so 3 minus 1 is 2. So f of x is equal to 2 we are getting at x is equal to 2. Then the derivative of f of x is equal to d by dx of 2, differentiation of a constant is 0 at x is equal to 2, we can say. So the answer is 0. If f of x is equal to x square upon mod x, then write the value of d by dx of f of x. From the definition of mod x is equal to plus x when x is greater than or equals to 0, and negative x when x is less than 0. So we can write x square upon mod x, that is f of x, which is equal to x square divided by x, that is x when x is greater than or equals to 0, and we can consider x square upon negative x, which is equal to minus x when x is less than 0. But the denominator x is there, so the domain of the function cannot be taken 0, so we'll just consider only x is greater than 0. So let us take the two intervals, x is greater than 0 and x is less than 0. And also one more point, mod x is not differentiable mod x is not differentiable at x is equal to 0. So let us not consider 0 case. Then differentiation d by dx of f of x is equal to, we can have differentiation of positive x which is equal to 1 when x is greater than 0, and differentiation d by dx of negative x which is equal to negative 1 in the case of x is less than 0. So we can say the two cases here, plus 1 and minus 1 for x is greater than 0 and for x is less than 0, 1 and minus 1 is the answer. Write the value of d by dx of log of mod x. So the given function f of x is equal to log of mod x, and we know that log x is defined for x is greater than 0. So and for any value of x, for any x belongs to R, we can say mod x is greater than or equals to 0, and here to define the logarithm, mod x should not be equal to 0. That is, x must not be equal to 0 is one case, and also we can just consider mod x is not differentiable. Mod x is not differentiable at x is equal to 0. So let us consider other than 0, and then now f of x is equal to log of mod x, then differentiation d by dx of log of mod x is equal to, as per the definition of d by dx of log x is equal to 1 upon x, where x is not equals to 0. So we can write here differentiation of log of mod x is 1 upon mod x, where x is not equals to 0 we can consider. If f of 1 is equal to 1 and f dash of 1 is equal to 2, then write the value of limit x tends to 1 square root of f of x minus 1 upon root over x minus 1. As x tends to 1, so we can say f of 1 is equal to 1, so f of 1 tends to 1. We can just make a note, and let us multiply and divide with limit x tends to 1 root over f of x minus 1, or which can also be written f of x to the power of 1 by 2 minus 1, we can also write 1 by 2. So let us divide with f of x minus 1. So multiply with f of x minus 1, and then again the denominator 1 upon root over x minus 1, we can write it as x power 1 by 2 minus 1. So let us divide with x minus 1. It is divided with x minus 1 here, so that we can just here also divide with x minus 1. Just multiply and divide with x minus 1. So limit x tends to 1, f of x to the power of 1 by 2 minus 1 to the power of 1 by 2. Since we know that as limit x tends to a, x power n minus a power n upon x minus a is equal to n into a to the power of n minus 1. So f of x to the power of 1 by 2 minus 1 by 2. So here let us take separately here. Limit x tends to 1, f of x to the power of 1 by 2 minus 1 to the power of 1 by 2 divided by f of x minus 1 into limit x tends to 1, we can write here f of x minus 1 divided by x minus 1, and again into limit x tends to 1, we can write this as 1 upon or we can also write 1 upon limit x tends to 1 x power 1 by 2 minus 1 power 1 by 2 divided by x minus 1. So as limit x tends to 1, f of 1 tends to 1, so f of x also tends to 1. So we can write also that we can change the limit as x tends to 1, f of x tends to 1, since f of 1 is equal to 1 it is given. So f of x to the power of 1 by 2 minus 1 to the power of 1 by 2 divided by f of x minus 1 into, since we know that limit x tends to a or limit x tends to c, f of x minus f of c divided by x minus c is equal to f dash of c. So limit x tends to 1, f of x minus 1 upon x minus 1 is equal to f dash of 1 we can write into 1 upon, again by using this formula here, limit x tends to 1, x power n minus a power n by x minus a can be written 1 by 2 into a to the power of, that is 1 by 2 to the power of 1 to the power of 1 by 2 minus 1, and even here also we can apply the same, n into a to the power of, so that is 1 into, sorry 1 by 2 into a to the power, that is 1 to the power of 1 by 2 minus 1 into f dash of 1 into 1 divided by 1 by 2. So here 1 by 2 and 1 by 2 gets cancelled, so it is nothing but your f dash of 1, and it is given that f dash of 1 is equal to 2. So we can just write down the answer as 2 answer. Write the derivative of f of x is equal to 3 times mod of 2 plus x at x is equal to negative 3. Since we know that this function is not differentiable at x is equal to negative 2, since mod of x minus a is not differentiable at x is equal to a, and minus 3 is less than negative 2, so we can write mod of x plus 2, that is mod of 2 plus x, can be written x plus 2 when x is greater than or equals to negative 2, and we can write negative of x plus 2 when x is less than negative 2. Since x is equal to negative 3 which is less than minus 2, so we can write the function f of x is equal to, we can consider minus 3 times of x plus 2 for x is less than negative 2. So the differentiation, let us find the differentiation even in this interval. Differentiation of f of x which is equal to d by dx of minus 3 times of x plus 2, which is minus 3 times d by dx of x plus 2, that is minus 3 times of d by dx of x plus d by dx of 2. That is minus 3 into differentiation of x is 1 and differentiation of constant is 0, so we are getting negative 3. So it's an independent of x, so we can say differentiation of d by dx of f of x at x is equal to d by dx of f of x at x is equal to 3, or at x is equal to negative 3 is minus 3. If mod x less than 1 and y is equal to 1 plus x square plus x power 3 and so on, then write the value of, means and so on up to infinity we can consider, then write the value of dy by dx. Since for mod x less than 1, so y is equal to 1 plus x square is nothing but it's a geometric progression and it's a sum to infinity. We know sum to infinity sum to infinity in GP, a plus ar plus ar square and so on to infinity is nothing but a divided by 1 minus r for mod r is less than 1. So we can consider y is equal to a is nothing but 1 upon, so here a is equal to 1 and r is equal to x. So a upon 1 minus x we can write for mod x is less than 1. And now let us find the differentiation. dy dx of y, that is dy by dx is equal to d by dx of 1 upon 1 minus x. Since we know d by dx of 1 upon x is equal to minus 1 by x square, so we can write minus 1 upon 1 minus x whole square into, by applying the chain rule, into d by dx of again 1 minus x. So we can write minus 1 by 1 minus x whole square into 1 minus x, differentiation of 1 minus x is it's a negative 1. So that is 1 upon 1 minus x whole square. So the answer is differentiation of the given problem dy by dx is equal to 1 upon 1 minus x square. If f of x is equal to log x power 3 to the base x square, then write the value of f dash of x. And we know the from properties of logarithm, log a power m to the base b power n is equal to m upon n log a to the base b. And also log a to the base a is equal to 1. So we can consider f of x is equal to, by using the first property, 3 upon 2, we can write log x to the base x. And again log a to the base is by using second property, we can write 3 by 2 into 1, that is 3 by 2. And then differentiation f dash of x is equal to d by dx of f of x, that is d by dx of 3 by 2. So it's a 3 by 2 is a constant and we know differentiation of a constant is 0. So the answer is 0. Okay.